See, beta, today our lecture will be about SNI, which is one of the nucleophilic substitution mechanism. We studied about SN1, we studied about SN2. Today we will study about SNI. What is SNI mechanism? So in SNI mechanism, what we have to do, so let's say we have an alcohol and we need to convert an alcohol to alkyl halide. So these two reactions we have learned. If we go through SOCl2, thionyl chloride, and if we go through SOCl2, it will make us alkyl halide SO2 and HCl. And this SO2 and HCl are gases and will be removed. And this reaction was the best method for preparation of alkyl halides from alcohols. And we have learned that this is the best method. And in second way also you can do this. Let's say we have SOCl2 plus pyridine. We have SOCl2 plus pyridine if we have. है ना? So अगर SOCl2 और pyridine के साथ अगर reaction कराते तो we will go through SN2 mechanism. If simple SOCl2 is written, it is SNI. So both of these mechanism today we will learn what is SNI and SN2 you already know. So let's say we take an example of this chiral carbon. This carbon is chiral, all the four groups are different. And in this chiral carbon, if I put SOCl2, so what will happen? तो यहाँ पर OH की जगह in place of OH you will get Cl. In place of OH you will get Cl with retention of configuration. Retention का मतलब अगर यहाँ पर R है यहाँ पर भी R होगा. रिटेन किया कॉन्फ़िगरेशन. अगर यहाँ पर S है तो यहाँ पर भी S होगा, है ना? सेम रिएक्शन इफ आई डू थ्रू SOCl2 pyridine, it will be through SN2 mechanism. और SN2 mechanism में हमें पता है कि हमेशा इन्वर्जन होता है. Every time where we have SN2 mechanism, it is always inversion of configuration. तो यहाँ पर inversion का मतलब OH के opposite पे you will get Cl, alkyl halide. If I want to convert from OH to Cl, so I can do by SNI and SN2 both mechanism. But if I want retention, I have to put SOCl2. But if I want inversion, so if I want inversion, I need to put SOCl2 with pyridine. याद रखें, this is one example. है ना? So mechanism of this SNI, we will study mechanism of SNI. So let's say we have an alcohol and you put SOCl2, thionyl chloride, SOCl2, है ना? अगर हमारे पास यहाँ पर ये अल्कोहल है, इसके अंदर मैं SOCl2 पुट करता हूँ, so what will happen? This OH will act as a nucleophile. This OH will act as a nucleophile and will attack the sulfur. है ना? अगर ये सल्फर को अटैक करता, so see, if it attacks the sulfur and this double bond will shift to O, देखें यहाँ पर, let's say I am drawing this again. Let's say I have here CH3, here I have H, here OH and here I have phenyl. अगर ये वाला यहाँ पर OH will act as a nucleophilic center, it will attack at electrophiles of del negative and oxygen del positive. ये nucleophile will attack at electrophilic center, electrophile पे, positive पे, है ना? Electrons will attack at positive centers. तो पॉजिटिव पे अटैक किया, दिस डबल बॉन्ड विल शिफ्ट टुवर्ड्स ऑक्सीजन. देखें, इफ दिस डबल बॉन्ड विल शिफ्ट टुवर्ड्स ऑक्सीजन, तो व्हाट विल हैपन? यहां से इसने सल्फर के साथ बॉन्ड बना लिया, है ना? ठीक. एंड सल्फर के साथ बॉन्ड बनाने पे ऑक्सीजन पे नेगेटिव आया. नाउ ऑक्सीजन नेगेटिव विल अगेन मेक डबल बॉन्ड and this chlorine minus will remove because chlorine is a good leaving group. Alkyl halides are good leaving group, you all know, है ना? If chlorine minus here If chlorine minus is gone, so what is made? CH3, H, pH, OH positive. Then you have sulfur. Then you have double bond of oxygen and one chlorine is left. This double bond of oxygen is made and one chlorine is made of Cl. So this is made, है ना? तो ये क्या करता है, यहाँ पर अटैक करता, ये क्या करेगा? This will attack on sulfur. This will go on oxygen electrons. This oxygen will come back again on double bond to make double bond. And one chlorine will be lost. One chlorine will be lost as leaving group. So this will happen. है ना? Similarly, here it is happening. क्या हुआ कि OH will attack on sulfur because OH is nucleophilic center. It will attack on electrophilic center. सल्फर पे अटैक किया, ये डबल बॉन्ड विल शिफ्ट ऑन ऑक्सीजन, दिस ऑक्सीजन विल कम अगेन बैक एंड दिस क्लोरीन विल लीव बिकॉज क्लोरीन इज गुड लीविंग. So this is made. Now what will happen? So this chlorine bond and sulfur bond which is very weak, so this chlorine will attack, this chlorine minus will act as a nucleophile and will attack internally, internal SN, इंटरनल न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन. सो दिस यहाँ पर अटैक करके यहाँ पर अटैक करता है और ऑक्सीजन को ब्रेक कर देता. सो यू विल गेट SO2, है ना? ये डबल बॉन्ड विल शिफ्ट टू दिस डबल बॉन्ड, तो यू विल गेट S डबल बॉन्ड O डबल बॉन्ड SO2, है ना? ये SO2 बन गया और ये क्लोरीन अटैक होके ये वाले कार्बन पे आ गया. सो इन द प्लेस ऑफ OH यू विल गेट क्लोरीन with retention of configuration. वहीं पर आ गए. Where there was OH, in that place you will get chlorine, है ना? तो इसको हम क्या कहते हैं? Retention. Therefore this reaction is known as SNI, internal. SNI, internal nucleophilic substitution. मतलब अंदर से ही अटैक हुआ, क्लोरीन बाहर से नहीं आया, कोई न्यूक्लियोफाइल बाहर से नहीं आया, अंदर ही अटैक हो गया. इसको SNI रिएक्शन कहते हैं. Second one is example, let's say we have SOCl2 with pyridine. This is known as pyridine. If I have SOCl2 with pyridine, if this OH will attack on sulfur or ye double bond will shift on oxygen, this oxygen will come back again and chlorine minus will leave. है ना? Similar way as SNY reaction. Similar way of SNI reaction. है ना? So same way as above, this one is made. And so what will happen now? Pyridine will act as a base. Pyridine being a base will take the hydrogen of this. है ना? इसका हाइड्रोजन ले लिया. इसका हाइड्रोजन ले लिया तो हमारे पास ये प्रोडक्ट बना, है ना? हमारे पास ये प्रोडक्ट बना. Once this product is made, now chlorine minus will attack as a nucleophile, backside attack, and because this is SN2 mechanism, SN2 mechanism this is, so it will attack from backside and remove SO2Cl. Remove what? SO2Cl. See this again, है ना? यहाँ पर क्या हुआ? Same way it was before attack of chlorine here. Before attack of chlorine, pyridine will come and will do the acid-base reaction. Beta, this is which reaction? Acid-base reaction. And I have always told that order of reaction should be, first should be acid-base, then should be addition, then should be substitution, and last is the elimination. So there is a competition between substitution reaction and acid-base reaction, है ना? So this, if chlorine minus goes and attacks, this is substitution reaction. But if base will take hydrogen from here, this is acid-base reaction. Acid-base, है ना? So order of our priority should be first the acid-base and then the substitution. अगर यहाँ पर पहले एसिड बेस रिएक्शन हो गया, so this chlorine minus, now you can do substitution. Now you should know which is the mechanism of this reaction. तो अगर आप यहाँ पर क्लोरीन माइनस विल अटैक फ्रॉम बैक साइड एंड दिस SOCl SO2Cl will be removed as leaving group because it is a good leaving group SO2Cl. तो SO2Cl निकल जाता and chlorine minus will go from backside, therefore we will get inversion product, है ना. सो SN2 रिएक्शन में हमेशा याद करना we will get inversion. और SNI में हमारे पास रिटेंशन होता है, रिटेंशन, है ना. दीज आर टू एग्जांपल्स ऑफ SNI एंड SN2 मैकेनिज्म. सो वेयर देयर इज SOCl2, बस पिरिडीन, जहां पर भी आपको पिरिडीन दिखेगा आपको याद करना SN2 होगा. अगर पिरिडीन नहीं दिखा, if there was no pyridine with SOCl2, you will always remember SNI and you should always have inversion. SNI में सॉरी SNI में रिटेंशन होती है, SNI में रिटेंशन होती है, रिटेंशन, और SN2 में इन्वर्जन. सो SNI मैकेनिज्म में रिटेंशन होता है, SNI मैकेनिज्म में रिटेंशन होता है, सेम से सेम, RS विल बी सेम, बट SN2 में इन्वर्जन होता है. दिस यू शुड रिमेंबर. So summary I am telling you today. Let's say we will write our summary that if simple SOCl2 is given, you should have SNI mechanism, और SNI mechanism में हमारे पास retention, we will get retention product. And if I have SOCl2 plus pyridine, if I have SOCl2 pyridine, we will get SN2 mechanism and we will get our inversion product. Done? Don't worry, beta, I will upload. Don't worry, beta, you will get all these files. I will upload everywhere. I will upload. So this was all about our SN mechanism. SN mechanism में हमने पढ़ा nucleophilic substitution. We have studied about SN1. We have studied about SN2. We studied about SNI. These are three mechanism of SN1, SN2, and SN. है ना? Simple it was. Nucleophilic substitution was of three types: SN1, SN2, and last was SNI. SN1 में अगर let's say we have alkyl halide nucleophile, before coming of nucleophile this bond will break due to solvolysis के कारण, so we will get R positive and X negative. Now this nucleophile will come and attack on R positive to give you R and nucleophile, है ना. ये आपको पता है, यहाँ पर कार्बोकटायन बनता है SN1 में, 3 डिग्री अल्काइल हैलाइड मोर स्टेबल होते हैं, 3 डिग्री कार्बोकटायन मोर इजीली टू मेक, है ना. दिस इज ऑल SN1 रिएक्शन. SN2 में यू ऑल नो, अगर SN2 करवाना है तो यू शुड कम एंड अटैक फ्रॉम बैक साइड, at the sigma anti-bonding orbital and leaving group will leave, है ना. So nucleophile and R bond will be made, and this is always, you know, in SN2 mechanism we always have inversion. Last is SNI. अगर SNI है you should have alcohols. अल्कोहल में अगर हमारा कोई SOCl2 अटैक करता, और अगर ये अटैक हो रहा है you will get RCl, and it is through SNI मतलब न्यूक्लियोफिलिक सब्स्टिट्यूशन इंटरनल, है ना. अगर RCl हुआ, इंटरनल हुआ, you will always know it is retention of product, रिटेंशन होगा यहाँ. Mechanism I have told today only. Mechanism you all know that this OH will come and will attack of SOCl will go. है ना, and then internal Cl will go and attack on carbon. Internal Cl will go and attack on carbon. So always remember these three. Whenever we have SN1 we will have racemization. रेसमाइजेशन मतलब हमारे पास रेसमिक मिक्सचर होगा, है ना. Whenever we have SN2 we will get inversion product, and whenever we have SNI we will get retention product. So write in the chat box, did you understand or not? Write yes or no. These three mechanism, write yes or no. Because beta, see why do we get oxygen positive? Because oxygen will go and attack beta, है ना. If oxygen is going and attacking on sulfur, so both of its electrons are gone, therefore oxygen become positive. Therefore this bond of carbon and oxygen becomes weak. And if it becomes weak, therefore Cl minus will come and attack on this carbon to give us Cl minus will come and attack, Cl minus will come and attack on this carbon to remove this SO2Cl. देखो, to remove SO2, to remove SO2. Done? Simple it is. Was, sir, what happened to oxygen attached to oxygen positive? Beta, what happened to hydrogen? What happened to hydrogen attached to oxygen positive? What happened to hydrogen when it is attached to oxygen positive? वो तो निकल गया बेटा. It went with the solvent. Don't worry. हाइड्रोजन तो चला जाता है इधर उधर. ये हाइड्रोजन निकल गया किसके साथ? HCl के साथ. We learned, and a hydrogen removed with Cl minus to give us HCl. In the product also, you know what was product? SO2 will come and HCl will come with. Hasini. So HCl will remove from this. Then, sure. So today we will start our new chapter, which is about elimination reaction. है ना. So we learned in the last class कि whenever we have aqueous KOH, whenever we have aqueous KOH, we will do nucleophilic substitution reaction. And whenever we have alcoholic KOH, alcoholic KOH है अगर हमारे पास, मतलब KOH के साथ someone has given you alcohol also, है ना. अगर ये alcoholic KOH है तो ये alcohol, this KOH will act as a base, this alcohol will act as an acid, एसिड बेस रिएक्शन करके यहाँ पर बनेगा C2H5O माइनस, और यहाँ पर K पॉजिटिव NH2, है ना. ये बनेगा हमारा. So whenever we have aqueous KOH, this will act as a nucleophile and will attack on carbon to remove Cl. This you all know, है ना. अगर हमारे पास यहाँ पर, अगर हमारे पास यहाँ पर aqueous KOH है, this will attack on chlorine to remove, this will attack on carbon to remove Cl by any mechanism. It could be SN1, it could be SN2, it could be SNI, depending upon the substrate, the leaving group and the nucleophile, है ना. अगर 3 डिग्री है सबस्ट्रेट तो SN1 होगा. अगर सिंबल्स लेट्स से 1 डिग्री सबस्ट्रेट है तो SN2 होगा. अगर बेंजाइलिक है, एलाइलिक है तो SN1 होगा, बिकॉज कार्बोकैटायन स्टेबिलिटी यू हैव टू सी, है ना. If steric hindrance is there, so you should always do, if steric hindrance is there, you can't do SN2. If you have smaller substrate, you can do SN2 reaction in that, है ना. So let's say we have, today we will study about elimination reaction. Whenever we have alcoholic KOH in the arrow written as reagent, whenever we have alcoholic KOH written on the arrow, as reagent, we will always prefer elimination reaction, है ना. So elimination कैसे होता? This will act as a C2H5, O minus will act as a base. It will take hydrogen from the adjacent carbon, है ना. ये अल्फा कार्बन, ये बीटा कार्बन. It will take hydrogen and this will make a double bond, or from here Cl minus will be removed as leaving group, है ना. So today only we will study what are elimination reactions. So see, we have four types of elimination reactions, है ना. So first elimination reaction is alpha elimination. Elimination you all know. Elimination को क्या मतलब होता है? Elimination is removing of something from our substrate, and we have to remove something from our substrate. Let's say first example is alpha elimination. Alpha matlab, let's say I have to remove X and Y, both of these atoms from alpha carbon जिस पे attach है. So these X and Y are attached on only single carbon. So these are known as alpha elimination. अगर X यहाँ से अपना इलेक्ट्रॉन लेके चला गया और Y भी अपना इलेक्ट्रॉन लेके चला गया, both are removed, we will get carbene as intermediate, है ना. तो यहाँ पर एक इलेक्ट्रॉन is left from here, one electron is left from here. So these two electrons will be sitting and we will left with our carbene, है ना. Carbene are electron deficient species, you all know they are electron deficient in nature. So whenever we have alpha elimination, we will get carbene. Second one example which is there in your syllabus is beta elimination, है ना. Beta elimination का मतलब, let's say we have X and Y on two carbons, है ना. So let's say we have X and this carbon will be known as alpha carbon and the adjacent carbon will be known as beta carbon, है ना. If I remove X and Y from both the carbons, अगर ये दोनों को remove करते, we will get double bond, we will get alkene, है ना. We will get what? Alkene. अगर X और Y दोनों को हम निकाल लेते तो alkene होता. So we can remove beta elimination, we can do in two methods. First one is syn elimination. Syn मतलब दोनों X और Y are removing from same side, है ना. X and Y from same side. If we are removing X and Y from same side, if we are removing X and Y from same side, it is known as syn elimination. Syn मतलब एक साइड से निकाल लो दोनों X and Y को. And if I am removing X and Y from opposite side, this is known as anti-elimination. And both will give us alkene. Both will give us alkene. So always remember, in elimination we will get what? Alkenes. In elimination we will get what? Alkenes. Third one is also there, 1,3 elimination. 1,3 elimination में क्या होता कि अगर हमारे पास let's say first group is on 1, 2nd and 3rd position. First position, 2nd position and 3rd position. So this X will remove and Y will remove and will make here free radicals, and these free radical will combine with one another to give us cyclopropane ring, है ना. This free radical will combine with one another to give us cyclopropane ring. This is 1,3 elimination, है ना. बीटा एलिमिनेशन आपको हमेशा पता, दिस इज 1,2 एलिमिनेशन. बीटा एलिमिनेशन इज 1,2 एलिमिनेशन मतलब एक कार्बन और दूसरा कार्बन, एडजेसेंट टू कार्बन्स, दोनों में से दोनों ग्रुप रिमूव करते हैं. If you have two groups on two adjacent carbon, you can remove them. Fourth one is 1,4 elimination. 1,4 matlab, let's say you have X and Y on 1, 2, 3, 4th position, है ना. So what will happen? This will remove, X and Y will remove, X and Y will remove. If X and Y will remove, so ये वाला will make this single bond of X will make here double bond. This double bond will shift on this single bond and this Y will be removed. So you will get 1,3 diene, 1, 2, 3, 4. 1N3 डाइन, है ना। है ना, इसका नेम इफ यू राइट 1,3 ब्यूटाडाइन, 1,3 ब्यूटाडाइन, ब्यूटेन, 1 2 3 4 ब्यूट, है ना, वर्ड रूट इज ब्यूट, and diene because you have two double bonds, therefore diene we have used. देखें, समझ आ रहा है आपको? So elimination can be of four types. So elimination can be of four types. First is alpha elimination, second is beta elimination, third is 1,3 elimination, and fourth is 1,4 elimination. याद रखें अच्छे से। Done? Don't worry, beta. I will give you time to write all this, and this notes will also be shared to you. Better write this. I'm giving you 2 minutes. Write complete your notes. But don't worry, we will solve questions today. Then you will understand what types of questions will be asked in elimination reactions. I will give you homework also. Homework will be given to you. Don't worry. Once you solve the homework, after that you will come to know what types of question will be asked. First, understand the reaction mechanism. Today only we will solve some question. After that you will come to know. Written? Write yes or no in the chat box. Write yes or no in the chat box, beta. Write your doubts in the chat. I will solve in the ending. Don't worry. Completed, beta? Difference between SN1 and SNI reaction asked by Aparna. Beta, SN1 reaction is carbocation. You have to make carbocation. है ना? But SNI is totally different. SNI we converted from alcohol to alkyl halides using SOCl2. SNI you have retention. SN1 you will get racemization. Chalo. Let's shift to our next thing. So next thing is beta, देखें. Next thing is elimination reaction. What is elimination reaction? We will see today. So beta, elimination reaction also like SN1, SN2, it has also three mechanisms. First one is E1, another one E2, last one is E1CB. 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 See beta, in E1 reaction you will have order 1. Elimination, unimolecular elimination reaction. है ना, इसको क्या कहते हैं? Unimolecular एलिमिनेशन रिएक्शन। E2 क्या होता है, ऑर्डर कितना होना चाहिए E2 का, 2। इट इज बायमॉलिक्यूलर एलिमिनेशन रिएक्शन। And last one is E1CB. This is known as unimolecular unimolecular conjugate base unimolecular conjugate base elimination. Unimolecular conjugate base elimination. So the mechanism could be E1, E2, and E1CB. है ना? So we will understand today what is E1, what is E2, what is E1CB. Elimination कैसे करना है. How to do elimination, we will understand. And these all are 1-2 eliminations. These all are which type of elimination? 1-2 elimination, or also known as beta elimination. Beta elimination. So let's start with E1 elimination. E1 क्या होता है? Before the attack of any base. So we should have a base, है ना? Before the attack of any base on the hydrogen of this, अगर ये base attack hydrogen पे करता, this Br will remove itself. Before the attack of any base, this Br will remove itself to give us carbocation as intermediate. To give us carbocation as intermediate. Once this carbocation is made, now base can take the hydrogen of beta hydrogen. है ना? These two are known as, this is alpha carbon. These two are beta carbons. See, this is alpha carbon. This is alpha carbon on which bromine was attached. These two are beta carbon, उसके adjacent वाले कार्बन, है ना? So now base can come and take the hydrogen of the beta hydrogen of beta carbon, है ना? So beta hydrogen it can take from here, or it can take this hydrogen. Two possibilities there, है ना? दो possibility can happen. So if it takes from first one, you will get which product? अगर पहला वाला ले लिया, अगर B ये वाला लिया, let's say this is A, this is B, है ना? अगर A वाला लिया, so you will get here product CH3. अगर let's say A वाला लिया, so you will get here product CH3CH. अगर ये वाला हाइड्रोजन इसने ले लिया, और ये हाइड्रोजन लेने के बाद these two electron will shift and will make a double bond here. अगर ये दोनों यहाँ पर अटैक करके डबल बॉन्ड बनाया, तो डबल बॉन्ड विल कम हियर बेटा. And second possibility also, if base goes and take hydrogen from this side, so this double bond will shift this side, है ना? डबल बॉन्ड कहाँ बनाने का? यहाँ बनाएंगे डबल बॉन्ड, यहाँ पर CH2. So these two double bonds can be made from it, है ना? So in even mechanism, what we will have in even mechanism, देखें even mechanism में क्या है? Let's say we have here bromine or any leaving group. So before any base, let's say we have C2H5OH, alcoholic KOH. If on the arrow it is written alcoholic KOH, or we have C2H5OH, C2H5O minus K positive or Na positive, है ना? अगर यहाँ पर ये लिखा है, so before the attack only, it will remove the bromine and will make carbocation. Now C2H5O minus will come and will take the hydrogen from two things, है ना? हाइड्रोजन ले सकता है कहाँ से? अल्फा एंड बीटा. It can take from beta. So it has two beta. So it can take from this beta or this beta. So if it took from A position, अगर A से लिया, अगर A से लिया, so let's say what it has done. Let's say we have C2H5O minus. It has taken hydrogen from here. So this electrons will shift to this side and will make a double bond this side. Okay, and we'll make this alkene as product. But in second case, if it goes and take, if it goes and takes hydrogen from this side, C2H5O minus. If it goes and takes hydrogen from this side, this hydrogen will shift here and will make us this product. Just understand better. So two possibilities are there of taking the hydrogen from beta. So you removed chlorine, you removed here the bromine which was here present. You removed bromine and you have to remove one hydrogen from here or here. है ना? अगर ये वाला गया तो यहाँ पर डबल बॉन्ड आएगा, अगर ये दोनों चले गए तो यहाँ पे आएगा, है ना? सो यू हैव टू पॉसिबिलिटी, अगर ये वाला गया तो यहाँ पे डबल बॉन्ड आएगा, अगर दिस साइड इट इज गॉन सो योर डबल बॉन्ड विल बी मेड इन बिटवीन दिस, है ना? सो टू प्रोडक्ट्स यू विल गेट, one is major, other is minor. We will come to know which one is major and which one is. So this is the mechanism of E1, है ना? Another mechanism is E2 mechanism. E2 mechanism में क्या होता? Directly base will attack, let's say C2H5O minus, directly base will attack hydrogen, double bond will be made and bromine will be removed. Concerted mechanism, एक ही बारी में, है ना? Similar way of SN2, एक साइड ही बैक साइड से अटैक करके you remove leaving group, है ना? So similar as E2 में क्या होगा? Let's say we have this, let's say we have bromine here. Then now if I in this reaction put C2H5OH in C2H5OH, or on the arrow it is written alcoholic KOH. Once on the arrow it is written alcoholic KOH, you should know we should do elimination reaction, है ना? एलिमिनेशन कराना है. सो एलिमिनेशन कराने के लिए यू शुड हैव हियर अल्फा, दिस कार्बन, द कार्बन ऑफ ब्रोमीन इज नोन एज अल्फा, एडजेसेंट कार्बन को बीटा कहते हैं, है ना? अब बीटा से हमें हाइड्रोजन यू हैव टू रिमूव, सो इट कैन अटैक ऑन दिस हाइड्रोजन, टेक द हाइड्रोजन, मेक द डबल बॉन्ड, रिमूव द ब्रोमीन, है ना? सो यहाँ पर इट कैन हैव टू केसेस. It can make this as product 1. This is A. On another way, it can go and attack on this hydrogen. It can go and attack on this hydrogen directly. Will make double bond here and will remove bromine. So second one will be this product. देखिए, सो E1 एलिमिनेशन में क्या होता और E2 एलिमिनेशन में क्या होता? E2 में क्या होता? डायरेक्ट वन स्टेप कंसर्टेड मैकेनिज्म, वन स्टेप कंसर्टेड मैकेनिज्म. You have direct one step concerted mechanism. You have transition state. You have transition state. बट E1 में क्या होता है? E1 में हमारे पास डायरेक्ट नहीं होता है. We have to go through कार्बोकैटायन. First carbocations are made, then this will come and attack on beta hydrogen. Then our base will come and attack on beta hydrogen to give us two products. These two products. देख लें बेटा. Difference between E1 and E2 you should remember. So E1 में हमेशा remember like SN1, E1 में you make carbocation. E2 में direct one step concerted mechanism transition state, similar of E1 and SN1 and SN2. So we will today study, don't worry, we will today study E2 mechanism. What are E2 reactions? Let's say what we have on the arrow, if they have given you these things, if on the arrow these things are written like reagents such as C2H5O minus in alcohols, C2H5O minus in C2H5 ethyl alcohol. If this is written on the arrow, you should remember that it is elimination reaction. Second one, they have given you alcoholic KOH. Third one, if they write NaNH2, if they write NaNH2 in the reaction, you should do elimination. If they write tertiary butoxide, this is known as tertiary butoxide, 3-degree carbon with oxygen minus. If they write DBN in the arrow, if they write DBU on the arrow, these all things will do what? These all things are acting as a base. These all things are acting as a base. They will help us in doing elimination reaction. So how elimination occurs? Elimination में क्या करते हैं हम लोग? We convert from alkyl halide to alkenes. We are converting what from what? We are converting alkyl halides to alkenes. This you should remember it. So elimination reaction में क्या होता है? You have to eliminate two things X and Y from alpha and beta. है ना? इसी को हम क्या कहते हैं? इसी को हम कहते हैं 1-2 elimination. This is a type of 1-2 elimination or beta elimination. Means you have to remove hydrogen and Br. Hydrogen and Br from two positions, alpha and beta. Adjacent position से hydrogen और Br निकालना है. So you have two possibility to remove them. You can remove from here. Or another possibility is you can remove this one hydrogen and this bromine. है ना? So first possibility is you can remove HBr to make double bond here. Second possibility is you can remove this HBr to make double bond here. है ना? So the carbon on which bromine is attached is known as alpha carbon. The carbon on which bromine is attached is known as beta. है ना? देखें. Done. So इसका mechanism we will learn. So we will get our two products. One will be major, other will be the minor product. दो प्रोडक्ट मिलेंगे हमारे पास. One is major, other is minor. देख लें. So mechanism, the major one by, see beta, major and minor we will get through one rule which is known as Sedzev and Hoffman. Sedzev and Hoffman rule. व्हाट इज दिस सेट्जेफ एंड हॉफमैन रूल देखें। तो लेट्स से वी सी स्टेबिलिटी ऑफ एल्कीन्स हम देखते हैं। एल्कीन कौन सी एल्कीन इज नोन एट सेट्जेफ एंड विच एल्कीन इज नोन एज हॉफमैन एल्कीन। See beta, for alkene stability, if someone is talking about alkene stability, you should always know that stability is directly proportional to number of R group substituents attached on alkene. है ना, more R groups, more stable alkene. है ना, let's say we have simple alkene, hydrogen on both the sides, so this is very less stable. Next one will be R group on one carbon, next one will be two R groups on two carbons, third one will be two R groups on single carbon, ये वाली alkene. So more substituents are attached on carbon, more R groups attached on carbon, more stability it will give by hyperconjugation. You have learned by hyperconjugation more stability if more substituents are attached. So stability order of alkene is shown in this order. Then just see beta, अभी देखें. I will give you time to write. See, more substituted alkene, if you have more substituted alkene, these alkenes are known as, if you have more substituted alkenes, these alkenes are known as Sedzev alkene. Sedzev alkene. Sedzev. Or in another words, it is known as Zsev. Zsev, sometimes they have written Zsevs also, but you know it is known as Sedzev alkenes. So Jonesy alkene के ऊपर you have more R groups, you have more substitution on the alkenes. That alkenes are known as Sedzev alkenes. And if you have less substituted alkenes, those alkenes are known as Hofmann alkene. Hofmann alkenes. So these two are the two naming of alkene. If you have more substituent, that is known as Sedzev alkene. If you have less substituents on alkene, it is known as Hofmann alkene. So we will study these two alkenes, what they are called. है ना? So out of these two, this will be R major and this will be R minor. Why beta major? Because this alkene has more substituents. है ना? This has CH3 here, this has CH3 here. If I count alpha hydrogen here will be 3 plus 3. How many alpha hydrogen? 6 alpha hydrogen. And hyperconjugating structure, if I draw, we have 6 alpha hydrogen of here. Therefore, more alpha hydrogen, more stability of alkene by hyperconjugation. So this alkene have more substituent, therefore it is known as Sedzev alkene. अगर यहाँ पर if I count alpha hydrogen here will be how many? This alkene is there. You have to count alpha hydrogen on adjacent carbon. ये एल्कीन यहाँ पर है, इसके साथ वाले कार्बन पे जितने हाइड्रोजन होते हैं वो अल्फा हाइड्रोजन होते हैं, उसके एडजेसेंट कार्बन पे जितने हाइड्रोजन होते हैं वो अल्फा हाइड्रोजन होते हैं. तो यहाँ पर कितने अल्फा हाइड्रोजन है? यहाँ पर 2 अल्फा हाइड्रोजन. therefore these alpha hydrogen are less, substituents are less, therefore these are known as Hofmann alkene. So if someone asks you which one is Hofmann alkene, which one is Sedzev alkene, which one has more alpha hydrogen is known as Sedzev alkene, which one has less alpha hydrogen is known as Hofmann alkene. देख ले बेटा. सो वी विल सी द मैकेनिज्म कैसे हॉफमैन बनता है, कैसे सेट्सअप बनता है। देखें, लेट्स से आई हैव दिस ब्रोमीन एज अ लीविंग ग्रुप। This bromine act as a leaving group. This base will come. This base will come. E2 mechanism देखें, mechanism of E2. E2 क्या होगा? Concerted mechanism होगा, one step concerted mechanism होगा, one step concerted mechanism होगा, ट्रांजिशन स्टेट बनेगा, वन स्टेप कंसर्टेड मैकेनिज्म होगा, ट्रांजिशन स्टेट बनेगा। कैसे बनेगा? वी विल अंडरस्टैंड। लेट्स से वी हैव अ बेस CH3O माइनस। So first step, it can take hydrogen from here, will make double bond this side and will remove the leaving group, है ना? तो पहली चीज क्या करता है, यहाँ पर हाइड्रोजन को बेस यहाँ से लेता, यहाँ से डबल बॉन्ड इट विल मेक हेयर एंड विल रिमूव द leaving group. Second case, it can go to this beta carbon, two betas it has. So यहाँ पर जाएगा, ये वाले से डबल बॉन्ड बनाएगा और ब्रोमीन को निकाल देगा। So we will draw the transition state. अभी transition state draw करते हैं। Let's say oxygen CH3 will go and take the hydrogen of this. If it is going and taking the hydrogen, अगर यहाँ से ये इसका हाइड्रोजन लेने गया, यहाँ से इसका हाइड्रोजन लेने गया, this bond will start breaking and this double bond will start making and this leaving group will start removing, है ना? So bond breaking or bond breaking and making will start, है ना? ये डबल बॉन्ड विल स्टार्ट डेवलपिंग हियर और ये वाले दोनों टूटने लग गए, ये वाले दोनों टूटने लग गए and this double bond will start making it. This is known as transition state of this reaction. अगर इसने ये वाले हाइड्रोजन को अटैक किया तो ये वाली ट्रांजिशन स्टेट बनेगी। अगर इसने डाउन वाले हाइड्रोजन, दिस बीटा हाइड्रोजन इट अटैक्स, सो ये वाला डबल बॉन्ड बनेगा, है ना? अगर ये वाले बीटा हाइड्रोजन पे अटैक किया, ये वाले बीटा हाइड्रोजन पे अटैक किया, सो यहां से ये डबल बॉन्ड यहां बनेगा और ब्रोमीन माइनस विल रिमूव, है ना? सो इफ आई मेक द प्रोडक्ट फ्रॉम ए, if I make the product from A, that this hydrogen will be gone, this will be made double bond here, and this bromine minus will remove as leaving group. But if I make from product from B side से बनाऊं, तो क्या होगा? यहाँ पर डबल बॉन्ड आएगा and bromine minus will remove. So you will get two types of alkenes, है ना? दो तरह की एल्कीन हमें मिली। एलिमिनेशन रिएक्शन में उतनी एल्कीन you will get that many types of alkene. How many are beta hydrogens? If it does not have beta hydrogen, no elimination. If it does not have beta hydrogen, no elimination. You should have beta hydrogens. You should have beta hydrogens, है ना? यहाँ पर 2 hydrogens this side, 3 hydrogen this side, है ना? So you will get two products. One is known as Sedsev, another is known as Hoffman. अब Sedsev and Hoffman are two types of alkene. You all know. If you have more substituents on alkene, this is known as Sedsev alkene. If you have less substituent, and so out of these two, this one will be more stable. Therefore, this is our major product. Sedsev alkene is a major product. Beta, you have to remember that Sedsev alkene you have to make. You have to make Sedsev alkene anywhere you have bromine, है ना? देखें, let's say one example I am giving you. देखें, let's say this is one compound with bromine, CH3, CH2. One question I am giving you, you have to do. We will do this question. Let's say I have bromine here and I have CH3 and hydrogen. So if I put in this reaction alcoholic KOH or NaNH2, this all I have told, if I have these all compounds written on my arrow, you will always do what? Elimination. You have to do always elimination. So elimination कैसे करते? You should know elimination करने के लिए you should always have beta hydrogen. So you can take beta hydrogen from this side or this side, है ना? Let's say अगर मैं यहाँ पर A साइड से करूँ, अगर मैं यहाँ पर A साइड से करते हैं, so you will get which product? From A side you will get which product? Tell me. अगर यहाँ से इसने बेस ने your base comes and removes hydrogen from here, make double bond here, remove bromine, है ना? So your double bond will be made here. If I remove from B side, अगर मैं B side से remove करूं हाइड्रोजन को, तो ये हाइड्रोजन रिमूव हुआ, यहाँ डबल बॉन्ड हुआ, यहाँ ब्रोमीन निकल गया. So our product will be this. So out of A and B, which one is more major? Write in the chat box which one is more major. Sets up, which one is sets up, which one is Hoffman, right? See beta, this alkene is more stable because it has alpha hydrogen 3 plus here 2, 5. Here how many alpha hydrogen? Only 2. This only. है ना? This is alkene. The carbon on adjacent carbon is known as alpha. यहाँ पर alpha hydrogen 5 है, यहाँ 2 है. Therefore, this one above one is more stable. This one is major. A is major, and down is minor. And you all know if you have alkene, more substituents are there on the alkene, that is known as Sedgev, and less substituents are there on the alkene, it is known as Hoffman. So out of Hoffman and Sedgev, always remember Sedgev is always major product. याद रखें बेटा इसको. So this question, write in your copy. I'm giving you 2 minutes. चलें. Let's see stereochemistry of E2 reactions. See beta, if I remove H and Br, X is what? X is all halides. Chlorine, fluorine, bromine, iodine. You all know chlorine, fluorine, bromine, iodine. If I remove H and X from same side, this is syn elimination. If I remove H and X from opposite side, this is known as anti-elimination. So always remember, in E2 reaction, we always prefer anti-elimination. क्योंकि अगर यहाँ से बेस आया, it will have steric hindrance between X and base. So above it can't attack. It has to go from opposite side. So it has to take hydrogen from opposite side of X, and it will make double bond here. यहाँ पर डबल बॉन्ड बनाएगा और X को रिमूव करेगा। देखें, सो राइट द स्टीरियोकेमिस्ट्री ऑफ E2 रिएक्शन। देखें E2 में क्या होगा कि बेस विल कम and will take the hydrogen, base will come and will take the hydrogen, base will come and take the hydrogen, will make double bond, will remove the leaving group, धक्का मार के निकाल दिया उसको, डबल बॉन्ड बना। देखें, let's say one question we will do today हैं, write the stereochemistry, then I will give you questions, then we will do questions. Always remember that in E2 elimination we will always have anti elimination. E2 elimination में हमारे पास एंटी एलिमिनेशन होगा। एंटी का आपको पता लगा, एंटी मतलब ऑपोजिट साइड। यू हैव लर्नड इन कन्फर्मेशन, कन्फर्मेशन में एंटी पढ़ा, गॉच पढ़ा है ना। एंटी एलिमिनेशन आपको पता है, यू हैव लर्नड अबाउट गॉच, कन्फर्मेशन, स्टैगर्ड, स्क्यू, एंटी, है ना। दिस इज न्यूमन, दिस इज न्यूमन प्रोजेक्शन फॉर्मूला, न्यूमन प्रोजेक्शन फॉर्मूला है ना। सॉहॉर्स से न्यूमन, दिस वाज न्यूमन प्रोजेक्शन फॉर्मूला। इसको फ्रॉम हियर इफ आई अटैक फ्रॉम हाइड्रोजन दिस साइड इट विल मेक डबल बॉन्ड हियर एंड इट विल रिमूव x माइनस, है ना, फ्रॉम न्यूमैन्स। दिस इज सॉहॉर्स, सीसॉ, सॉहॉर्स प्रोजेक्शन फॉर्मूला है। से बेटा इन E2 एलिमिनेशन क्या होता है, बेस विल कम एंड विल अटैक ऑन एंटी पोजीशन, मतलब एंटी अटैक होगा, यहाँ से हाइड्रोजन को लेके जाएगा, यहाँ से डबल बॉन्ड। सो हाइड्रोजन शुड बी एंटी ऑफ एक्स, हाइड्रोजन शुड बी एंटी ऑफ एक्स, एक्स के एंटी होना चाहिए, एंटी, these two are anti, then only base will come and take। देखिए one example will do, one example if I do, let's say I have this chlorine, this is alpha carbon, this is beta carbon, this is beta carbon, then देखें, and on the arrow it is written alcoholic KOH, then so मेरे को अब हाइड्रोजन लेना है, I have to take hydrogen from beta carbon, है ना। दिस इज एलिमिनेशन रिएक्शन, आई हैव टू टेक हाइड्रोजन फ्रॉम बीटा कार्बन। अगर मेरे को E2 एलिमिनेशन कराना है, आई हैव टू डू E2 एलिमिनेशन, आई कैन टेक हाइड्रोजन फ्रॉम बीटा कार्बन, बट बीटा के कार्बन का हाइड्रोजन आई कैन टेक दिस बीटा हाइड्रोजन, आई कैन टेक दिस बीटा हाइड्रोजन, टू पॉसिबिलिटीज है देन। बट इन बिलो, इन अबव 1C, यहाँ पर देखें, इफ आई टेक फ्रॉम हेयर हाइड्रोजन, this hydrogen and this chlorine are same side, and both are where back, so it is not anti-attack, it is not anti-attack, this is sin, hydrogen and Cl same side, sin, so you cannot attack, so this one is not possible, this elimination is not possible, है ना। so another one R result we will get from where if OH1 OH minus will attack on the hydrogen which is above, hydrogen which is above, so this hydrogen and Cl are anti to one another, anti मतलब opposite, opposite to one another, एक दूसरे के opposite है। these two hydrogen, this hydrogen and this chlorine are anti to one another, है ना। देखें दिस हाइड्रोजन एंड क्लोरीन आर एंटी। ये ऊपर है, दूसरा वाला नीचे है। See, OH minus will come from above, will take the hydrogen, and this double bond will be shifted to this bond will be shifted to make double bond here, and Cl minus will be removed. So double bond will come where? Here. Understanding or not? तो ये ऊपर वाले हाइड्रोजन को रिमूव करके ये वाला प्रोडक्ट नहीं बना सकता। इट कांट मेक दिस प्रोडक्ट। ये वाला प्रोडक्ट नको, because it can't take hydrogen which is H and Cl both same side. These hydrogen H and Cl are on same side, है ना? You have to do anti elimination. You can't do syn elimination. You have to do anti elimination. Then this is the stereochemistry of E2 reaction. 1 minute I am giving you, write this, then we will do questions. Similar way यहाँ पर बताएं, same way it is. You have to tell in this. So this is the alpha carbon, this is the beta carbon. I have to take beta hydrogens, है ना? See beta, this hydrogen and this Cl is also same side, same. This Cl and this hydrogen also same side. Both are same sides. So कहाँ से लेगा? From where it can take? So it can't do E2 elimination. It can't take hydrogen from any side. It can't make elimination. It can't do elimination. E2 elimination नहीं कर सकता, सेम साइड से नहीं ले सकता, है ना? दिस इज आवर सेकंड एग्जांपल। ये हमारा सेकंड एग्जांपल है। राइट दीज टू एग्जांपल्स। ये दोनों एग्जांपल्स लिखें। चले, now we will solve some questions. Let's see. First question I am writing this. चल, based upon our elimination, first question देखें. Let's say I have this carbon, on this I have bromine, है ना. You have given alcoholic KOH, so you have to do elimination. अगर alcoholic KOH आया, elimination होगा, आपको पता है. elimination कहाँ से होगा, अल्फा से या बीटा से, है ना. elimination, so you have to remove H and Br, है ना. H और Br को निकालना है दोनों कार्बन से. एक से H निकालना है, दूसरे से Br निकालना है. तो OH माइनस एल्कोहलिक KOH में क्या होगा, OH माइनस विल कम, एल्कोहल का OH माइनस देखें यहाँ पर जस्ट दिस OH एल्कोहलिक KOH में here इसका base, how this will be making a base alcohol if I use let's say C2H5OH and KOH. So यहाँ से इसका base बनेगा C2H5O minus. This will be our base. It will go and attack C2H5O minus will attack where C2H5O minus will go and will attack the hydrogen of carbon. बीटा हाइड्रोजन पे अटैक करेगा, हाइड्रोजन को लेगा, डबल बॉन्ड यहाँ बनाएगा और ब्रोमीन को निकाल देगा. सिंपल. सो आर रिजल्ट विल बी व्हाट, आर रिजल्ट विल बी CH2 डबल बॉन्ड CH2, है ना. और कोई तो बीटा नहीं है इसके पास, ओनली वन बीटा कार्बन इट हैज, ओनली वन हाइड्रोजन, ओनली वन पॉसिबिलिटी इट हैज. डन. सो दिस इज आवर प्रोडक्ट. दिस इज आवर प्रोडक्ट. सेकेंड केस में देखें. लेट्स से आई हैव दिस एज बेस, दिस विल एक्ट एज अ बेस and I have to remove beta hydrogen. So this is our alpha carbon, this is one beta carbon, this is one beta carbon, this is one this is one beta carbon, this is one beta carbon, this is one beta. So out of these three I have to remove hydrogen from any one beta. कैमरा ऑन हो गया, ब्लर हटाओ एक बार, ब्लर हटाओ, कोई नहीं, ब्लर हटाओ. So let's say I have to remove hydrogen from any of the beta hydrogen, है ना. So let's say I remove from here. So our product, let's say first one will be this one, है ना. अगर मैंने यहां से रिमूव किया, अगर मैंने यहां से रिमूव किया तो यहाँ पर डबल बॉन्ड बनेगा, ये क्लोरीन चला जाएगा, है ना. तो पहला प्रोडक्ट तो ये वाला आया हमारे पास. सेकंड वन विल बी इफ I remove from here this carbon का हाइड्रोजन, so this will be made this side and this will be removed. So second one product will be R like this. देखें इसी को देखें हम लोग. अगर लेट से I have this chlorine, I have this one. अगर मैंने यहाँ पर वन हाइड्रोजन, इट हैज दिस हैज वन हाइड्रोजन, लेट से दिस हाइड्रोजन. अगर मैंने बेस को ये वाले हाइड्रोजन पे अटैक कराया, सो इट विल कम दिस साइड एंड दिस क्लोरीन विल रिमूव, है ना. सो यहाँ पर क्या बनेगा, यहाँ पर ऐसे ऐसे यहाँ पर डबल बॉन्ड बन जाए, है ना. दिस डबल बॉन्ड, इसको फॉर बेटर अंडरस्टैंडिंग आई विल मेक दिस लाइक like this. थर्ड वन लेट्स सी, है ना, अगर यहां से निकालेंगे, इफ आई रिमूव हाइड्रोजन फ्रॉम हेयर ऑल्सो, it will be also same product as these two, because these two are same. These two are same. So out of these two product, this one is our major, this one is our minor, because it has more substituents. अल्फा हाइड्रोजन यहाँ पर कितने हैं, 3 + 3 + 3 9. Here alpha hydrogen are 3 + 2. 3 + 2, here how many? 5. So this one is our major, this is our Sedgwick product, this one is Hoffman product, this one is Hoffman. So little difficult it is. एक बार फिर once more I will tell you. Let's say I have CH3 here. Same example I am taking, above one only. I have here chlorine. I have here CH3. I have here CH2. Here CH3. See, the same problem we have. Let's say in this I put C2H5O minus. So you have to take beta hydrogen. So how many beta carbons it has? 1 carbon, 2 carbon, 3 carbon. This is alpha carbon. Adjacent to this alpha carbon are known as beta carbon. So it can take this hydrogen, it can take this hydrogen, it can take this hydrogen, है ना? Let's say अगर मैंने ये वाला हाइड्रोजन लिया, तो यहाँ पर डबल बॉन्ड यहाँ आएगा, क्लोरीन माइनस विल गो अवे, है ना? सो पहला वाला प्रोडक्ट हमारा बनेगा कुछ ऐसे, 1 हाइड्रोजन गॉन, HCl gone, H and this H and this Cl gone, and double bond made between these two. If I take hydrogen from this side, this H and this Cl gone, double bond made between these two. देखें, but if I remove this hydrogen, so this H and this Cl gone, elimination, 1 2 elimination, beta elimination, beta elimination. So here this double bond will be made here, this double bond will be made here, और यहाँ पर हमारे पास ये बचेगा CH2 CH3, and here will be CH3. So these two are same beta, these two are same. So if I remove from here or here, it will be same product. Double bond will be made here or here, it will be same. See, then so this will be our major product, these two will be our minor, because here alpha hydrogen are how many? Alpha hydrogen are how many? 3 alpha hydrogen. This alpha hydrogen are which hydrogen? Adjacent to double bond. डबल बॉन्ड के साथ वाले कार्बन पे जितने अल्फा होते, जितने हाइड्रोजन होते हैं, उसको अल्फा हाइड्रोजन कहते हैं. तो यहाँ कितने, 3 + 3 + 3 हाउ मेनी, 9. हेयर अल्फा हाइड्रोजन हाउ मेनी, यहाँ काउंट करें, डबल बॉन्ड के साथ वाले पे कार्बन पे 2 + 3 5. सो दिस वन इज मोर स्टेबल, दिस इज मेजर, देयरफॉर इट इज नोन एज ZF, ZF, और इसको हॉफमैन कहते हैं. This is known as Hoffman alkene. This is known as Sedgwick alkene. So out of Hoffman and Sedgwick, we will always prefer to make Sedgwick alkene. समझ आ रहा है आपको? I can only see this. Sir, can you reveal second question? Simple it is, है ना? अगर बीटा से हाइड्रोजन you have to remove, you have to make double bond. It is known as elimination reaction. Major and minor, let's say if I am making a product, if I am getting more than 50% of product, it will be major product. And if I am getting less than 50%, it is the minor product. So write this. I'm giving you 2 minutes. Write this. Then we will shift to next question. Write yes or no in the comment box. Chat box में yes or no लिख दें. After writing yes, after writing, better write yes or no. Done. चले नेक्स्ट पे शिफ्ट करें. नेक्स्ट क्वेश्चन करें. लेट्स से आई हैव this alkene. This alkyl halide I have, and it is given NaNH2 in the reaction. Now you all know if it is given NaNH2 in the reaction, this is third question. If it is given NaNH2, you will always do elimination. E2 elimination करेंगे. अगर E2 elimination करेंगे, तो you have to remove hydrogen from beta carbon. So this is the alpha carbon, which is the adjacent of bromine. How many beta carbons it has? This one is 1 beta. This is 1 beta. This is 1. Done. So this is 1 beta. This is 1 beta carbon. This is 1 beta carbon. देखें. So if I remove from first, second and third, देखें तीनों से, if I remove from all the three, let's say which product will form. अगर पहले से हाइड्रोजन निकाला और यहाँ डबल बॉन्ड बनाया एंड ब्रोमीन इट इज रिमूव, तो यहाँ पर डबल बॉन्ड विल कम दिस साइड. सी फर्स्ट वन. सेकंड वन से देखें, इफ आई रिमूव हाइड्रोजन फ्रॉम सेकंड here, if base will come, remove hydrogen, make double bond, remove bromine. So second one, double bond will be made here, this bond. देखें. This is second. अगर third one, if I attack this base on this beta hydrogen, make double bond here, remove the bromine. So I can make double bond this side. So I have this product, third one. So three products I have from here. So which one is the major product out of all the three? Write 1, 2, 3. Write the answer 1, 2, 3. Count alpha hydrogen in all the three. Count alpha hydrogen in all the three. Which one is the major product? Write in the chat box. 3 1 is the major product. Third one is the major product. देखें, here alpha hydrogen, this is alkene, this one carbon and this one carbon. यहाँ पर 2 हाइड्रोजन, यहाँ पर 1 हाइड्रोजन, 3 alpha hydrogen here. Here tell, this has 2 hydrogen here. देखें, this is alpha carbon, alpha carbon, alpha to alkene, alpha to alkene. How many hydrogen here? 3, 4, 5, 6, 6 here. But how many here? Check. This is alkene are this carbon, this carbon, this carbon, and this carbon. So 3 plus 3, 6 plus 2, 8 plus 2, 10. 3, 3, 6, 7, 8, 9, 10. So out of all the 3, third one will be our major product. Third one will be our major product. This means if I have this bromine here and this one NaNH2, so this base will go and take the hydrogen from where? This base will go and take this hydrogen to make this alkene, to make here alkene, our third product, which is our major product. समझे? It's simple. So you have to make the product which is more stable alkene, है ना? So our product should be more stable alkene. Simple this is. Third question it was. Write this beta. But I made little hosh posh, but I should write. Same question, see beta. So NaNH2, Na positive, NH2 negative will act as a base. It will take which hydrogen? This is alpha, this is beta, this is beta, and this is beta. है ना? तो कौन सा hydrogen it will take? It have this possibility, it has this possibility, it has this possibility. So it will go and take this hydrogen, will make a double bond and will remove the Br5. So our product will be made here, right? So this is our major product. Done. Complete this beta. Write this. 2 minutes I'm giving to you. Write yes or no. In the chat box after writing this, write yes or no. Sure. So last question also solve. One more question left. So out of these 4 questions, first one done, सेकंड वन डन, थर्ड वन डन, थर्ड वन भी हमने किया है। फोर्थ वन सी, fourth one you have to do. So I have here iodine and I have double bond here. So if I put in this reaction alcoholic KOH, fourth question देखें कैसे करना है। Let's say this is alcoholic KOH, this is the alpha carbon, this is one beta carbon, if I this is another beta. Done. So he can take hydrogen from this side, make double bond here. He can take hydrogen from this side, make double bond. So first possibility, second possibility. If I am making first one, देखें अगर मैं पहला वाला बनाऊंगा तो आई कैन टेक हाइड्रोजन फ्रॉम हियर, मेक डबल बॉन्ड दिस साइड एंड रिमूव I माइनस। दिस इज E2 एलिमिनेशन, तो मैं यहाँ डबल बॉन्ड बना दूंगा। दिस वन इज माय फर्स्ट प्रोडक्ट। सेकंड वन इफ आई डू, I will take hydrogen from this side, make double bond here, remove I minus. So our product will be this double. So out of 1 and 2, which will be our major and which will be minor? Tell me. Write in the chat box which one is major, which one is minor. Which hydrogen will be major and which alkene will be major, which will be minor. And write the reason also. Write the reason also. Second one is major or first one is major. Tell me which one is major. Out of 1 and 2, which one is major? One is major or two is major? Beta, see in these two, one is major because it has resonance, delocalization, and these two alkene bonds are isolated alkene bonds. These two have resonance. है ना? This can go for resonance. यहाँ से यहाँ shifting of electrons. Pi resonance. Here you cannot shift these electrons toward this side because you have CH3 here. For resonance, you should have pi bond, sigma bond, and then pi bond. Only one sigma should be there between two pi. Here I cannot do resonance. I cannot shift these electrons towards with this. So out of 1 and 2, conjugation, because of conjugation or because of resonance, same it is. Because of conjugation, pi conjugation है इसके अंदर, therefore this one is more stable than this one. More stable मतलब major. Major, more stable. More stable, less energy. Done. So this is our answer. This is our answer. Done. देखें those who were writing. But we have more alpha hydrogen in 2 beta. See beta, alpha hydrogen we count for hyperconjugation. Alpha hydrogen we count for hyperconjugation, but here is what? Resonance. Resonance is greater effect than alpha hydrogen. है ना? Resonance is greater effect than alpha hydrogen. है ना? Always remember aromaticity. First is aromaticity, which effects you have to see. Second one is resonance. Then mesomeric. Then you have hyperconjugation. And last one is inductive. है ना? So we will never talk about alpha hydrogen if we have resonance and mesomeric. है ना? Very good. But we have more alpha hydrogen in 2. Yes, I know it has more alpha hydrogen, but we have resonance also. Resonance also. One resonance will give you 6 alpha hydrogens. If I try to convert resonance into hyperconjugation, one resonance will give you 6 alpha hydrogens. So it has one resonance plus how many alpha hydrogen? 2 plus 2, 4. But here alpha hydrogen will be 4. So one alpha hydrogen is giving me 6 alpha hydrogens. 6 plus 4 will be giving you 10 alpha hydrogens. Here is only 4. याद रखें बेटा, this order you should remember. First always see aromaticity, then resonance, mesomeric, then see hyperconjugation, last see inductive. है ना? In the last you will see inductive. चलो, done. Sure. Last see beta. Questions only solved today. But these questions are homework to you. These questions are homework to you. These questions are homework to you. I will give you hint one by one. देखें.
No, I actually started in the past. You started or yes, when they lose. Then it's like one time they will make. Why you tell that I never much confidence.
Who cannot got in late for the class. That's why he's overcome this thing.
I don't think it's good. You must be nine.
First question, beta see.
But go at 11:15.
Let's say this is alpha, this is our beta, this is 1 beta. From where hydrogen you have to remove to make the major product. If I remove from here hydrogen, this HN and this Cl, it will make double bond here. If I remove hydrogen here, it will make double bond here. But this double bond will be our more stable product. So answer will be this. This is our major. Minor, no one cares. Mechanism, you know. Just write the product. Let's see, you can write better. Second one, see, if this is my alpha, this is my beta, this is my beta. If I remove from here, I will make double bond here. If I remove hydrogen and Br from here, I will make double bond here. And this double bond will be in conjugation with this double bond. Then if I remove from here, I will make double bond here. But this double bond will not be in conjugation with these two double bonds. Therefore, our major product will be this double. So I have to remove hydrogen from here, make double bond, remove Br. Done. देखें, एक जगह से धक्का मारे, दूसरी जगह से डबल बॉन्ड बनाए, तीसरी जगह से लीविंग ग्रुप को बाहर निकालें, है ना। एक जगह से पैसे ले लें, दूसरी जगह डबल बॉन्ड बनाए, तीसरी जगह से लीविंग ग्रुप को बाहर निकालें। This all is going on nowadays, beta.
Okay.
Third one also see, let's say we have OTS. Here leaving group is OTS, O-tosyl. This is our leaving group, है ना? So if I want to take hydrogen, this is alpha, this is beta, this is beta. Then, so it has two possibility. It can take hydrogen from this side and it can take hydrogen from this side. But this hydrogen and this leaving group are same side. So we cannot do here elimination. We cannot take this one. So it will go and it will take this hydrogen and it will make this alkene as this whole. तो ये वाला यहाँ से जाके from above it will go, from above hydrogen it will take, make double bond, remove the OTS from back side, पीछे से, है ना। So this will be our major product in respect to this one, because this hydrogen can't be moved. We cannot take this hydrogen because both are same side. Leaving group and this hydrogen are same side. Syn elimination. We cannot do syn elimination. We have to do anti-elimination. देखें, simple it is. Write these three beta in your copy. Similarly, these all are your homeworks, beta. But I will help you to do your homework today only. Don't worry. सेवंथ वन डू, सेवंथ वन रहने दें, पहले आप करें कौन सा वाला, आप करें you do fifth one. Fifth one, try to solve. This is alpha carbon. This is alpha carbon. This one is the beta carbon. And this one is the beta carbon. दो बीटा कार्बन है इसके, दो एडजेसेंट कार्बन बीटा कार्बन है। अब यहां से हाइड्रोजन निकाले या यहां से हाइड्रोजन, इट ऑल्सो हैज टू हाइड्रोजन बेटा, दिस कार्बन ऑल्सो हैव टू हाइड्रोजन, टू valencies are shown, two are not shown, hydrogens are not shown, bond line formula it is. So it can take hydrogen from this side. See beta, it cannot take hydrogen from this side because Br and hydrogen will be same side. So it will go and take the hydrogen from एंटी एलिमिनेशन करना, वहां से हाइड्रोजन लेते, डबल बॉन्ड बनाते, Br माइनस को निकालते. So our product will be double bond came here, phenyl and hydrogen. See, bromine minus gone, double bond made here, and this. Then simple it is. Similarly, fourth one also solve. यहाँ पर this is alpha, this one is beta. This one is alpha, this one is beta. Beta पे हाइड्रोजन कितने? ये only this hydrogen it है. It will go back side से जाके यहाँ डबल बॉन्ड बनाएगा, एंटी एलिमिनेशन करेगा. क्लोरीन माइनस कौन? एंटी एलिमिनेशन करेगा, HCl गॉन, H and Cl gone, elimination done. डबल बॉन्ड मेड बिटवीन दीज टू. तो यहाँ पर अगर इन दोनों के बीच में डबल बॉन्ड बनाया तो फिनाइल बैक CH3 फॉरवर्ड, here फिनाइल फॉरवर्ड CH3. This alkene we will get. देखिए यहाँ पर डबल बॉन्ड बनाएंगे, CH3 and this phenyl will be same side, this CH3 and this phenyl will be same side. देखिए तो write yes or no, write in your copies these questions बेटा. So elimination में क्या करना है? Finally I am telling you, write in your copies, I will share the notes to you. So elimination में क्या करना है? Let's say अगर कोई भी आपके पास, let's say this is my leaving group, bromine, chlorine, bromine, these are all leaving groups बेटा. If I have a leaving group, if any base comes, base like NaNH2 minus, like alcoholic KOH, like C2H5O minus, K positive, any base, DBU, DBN, these are all bases. So this base will come and will take the hydrogen from where? From beta hydrogen, from beta side. है ना, ये तो बीटा हाइड्रोजन लेगा. सो दिस वन इज बी अल्फा, दिस वन इज बीटा. डन. तो अगर ये यहां से हाइड्रोजन लेगा, इट विल टेक हाइड्रोजन, इट विल मेक डबल बॉन्ड एयर, ब्रोमीन माइनस बॉन्ड, एंटी अटैक, एंटी एंटी. और यहां से लेगा तो यहां बनाएगा ब्रोमीन माइनस बॉन्ड. सो इट कैन मेक टू प्रोडक्ट्स, दिस वन and it can make this product. So if it takes from one, it will make this product. If it takes from two, it will make this product. See. So E2 elimination में always remember, E2 elimination में हमेशा हमें याद करना है, you should have a base. Once base you know, you should go to beta hydrogen. If it has beta hydrogen, then okay. If no beta hydrogen, let's say this example, let's say this. यहाँ पर if I put alcoholic KOH, now you know it is elimination, you have to do elimination, but it does not have, this one is alpha, this is beta. It does not have beta hydrogen. Beta hydrogen ही नको नहीं है. If it does not have beta hydrogen, it cannot go and take anyone. है ना, तो यहाँ पर तो no E2 elimination, no E2 reaction. It should have beta hydrogen. So necessary condition for E2 is, it should have a base, it should have beta hydrogen should be present, at least one. Beta hydrogen should be at least one should be present. Then it should have be anti-elimination होना चाहिए for stereochemistry के लिए. It should be anti-elimination. है ना, याद करना है आपको. We should always prefer ZZ product in respect to Hoffman product. है ना, we will always prefer, हाँ last, we will always prefer to have सेटजेप प्रोडक्ट इन रिस्पेक्ट टू हॉफमैन एल्कीन, है ना? हमेशा हमारे पास सेटजेप एल्कीन इज मोर स्टेबल देन हॉफमैन एल्कीन, आपको याद रखना है ना? whenever you have conjugations whenever you have conjugations you will always try to make conjugated alkene, है ना? आपको हमेशा conjugated alkene बनानी है where you get resonance. We have done this question also. So this is our main crux of today's lecture, that how E2 elimination goes. This is our main so this is was our main crux of this chapter, that how E2 elimination is done, है ना? For E2 elimination you should have a base, you should have an beta hydrogen, you should do anti-elimination, Sadzap should be greater than Hoffman, you should always have conjugation to make alkenes, है ना? If you have any doubt in this you can ask better. If you have any doubt in this you can ask. I will unmute you, then you can ask your doubts.